An important chapter which we deal with in chemistry now is atomic structure, classification of elements and periodicity in their properties. Now in atomic structure, these are the basic formulas which you should always remember. In the Bose model of atom, the energy of the atom in the nth orbital is given to be minus 13.6 into z square upon n square. Here z is the atomic number of the element and n is the number of the principal quantum number of the orbit in which the electron is present. This is the velocity of the electron in the nth orbit. This z is again the atomic number. You must also remember this formula that v is equal to 2.18 into 10 raised by 6 into z upon n meters per second. mvr is equal to nh upon 2 pi, as we already know. This is the angular momentum of the electron in the nth orbit, and that is the function that is equal to nh upon 2 pi. That the angular momentum is always quantized. The radius of the nth orbit is given to be 0.529 angstrom into n square upon z. You should also remember these small things, that the potential energy of an electron in a particular orbit is equal to 2 times the total energy, and the kinetic energy is equal to minus of total energy, where the total energy is given by minus 13.6 into z square upon n square electron volts. Now also, if you need to find out the energy of a photon in electron volt, when you are given the wavelength of the electron or the wavelength of the photon, sorry, then you can use this formula. Just use 12,400 upon lambda in angstrom. Suppose the wavelength of the photon is given to be 6,000, then you feed in 6,000 angstrom, then you feed in 12,400 upon 6,000 to get the energy of that photon in electron volt. These are the some of the small formulas which you should remember for solving out the questions easily and faster. So we begin with our questions now. Now here's the first question. We have been given that 1 mole of helium plus ions is excited. 50% of the ions are in the second excited state. The rest 25% are in the first excited state, and the last 25% is in the ground state. We need to find out the total energy evolved when all ions return to the ground state. So this is a pretty simple question if you know the energy level diagram for helium plus ion. Helium plus ion is a single electronic species that is similar to hydrogen atom, and we can apply Bose theory to this atom. You must also always know how to draw the energy level diagrams properly. Let this be the n is equal to 1 state. And there is one more thing you should remember or notice carefully in this question. We have been given second excited state. So always be careful when the word excited state is written. Whenever there is written excited state, it means n plus 1th state. That is, the second excited state is equal to the third state. The first excited state is equal to the second state. N is equal to 1 is known as ground state. So this is equal to n is equal to 1. Here we have n is equal to 2. Here we have n is equal to 3. And subsequently n is equal to 4. You must notice that the gap between the two levels keeps on decreasing as we go upwards. N is equal to 5 will be something like this. So the energy level diagram should always be drawn properly like this, with gaps reducing constantly. This gives you an idea of actually the energy difference between the two levels. The energy difference between n is equal to 2 and n is equal to 3 will be smaller than the energy difference between n is equal to 1 and n is equal to 2. You can also check that. Let us find out the values of the energies first. We know the energy to be equal to minus 13.6 electron volt into z square upon n square. Z is equal to 2 for helium. Therefore 2 square upon n square, that is equal to minus 54.4 upon n square electron volts. So we get the energy for the first level to be equal to minus 54.4 electron volt. The energy for the second level comes out to be minus 54.4 upon 4, that is equal to minus 13.6 electron volts. The energy for the third level comes out to be equal to minus 6.04 electron volts. We do not need the energies for the other levels, so we do not calculate them. Actually, you should also remember the energies of the first few levels of at least hydrogen and helium plus ions. So you should remember these energies actually minus 54.4, minus 13.6, minus 6.04. It just helps in doing the calculations faster. So let us solve this question. We have total of 1 mole ions, out of which 50% is in the second state, second excited state, that is the third state. That is, we have 0.5 moles of ion here. We have another 0.25 mole of ions at this state, and another 0.25 mole of ions in the ground state. So nothing happens to these 0.25 mole ions, so we forget them because they remain in ground state. Now when the ions come from the n is equal to 2 to n is equal to 1 and n is equal to 3 to n is equal to 1, they release some energy, because n is equal to 3 is a high energy state, then n is equal to 1, minus 54.4 is, mind you, is smaller than minus 6.04 or minus 13.6. So this is the lowest energy state because it is closest to the nucleus, therefore this is the lowest energy state, and the atom is and the electron will be more stable over here. Now as the electron or as the atom comes down from this state to this state, what happens is that it releases energy because its energy becomes reduced. So the amount, let us calculate the amount of energy that is reduced when the energy difference between E3 and E1 is equal to, that is the energy difference between these two states comes out to be equal to 54.4 minus 6.04 electron volt, that is equal to 48.36 electron volts. Now again E2 minus E1 is equal to 54.4 minus 13.6 electron volt, which comes out to be equal to 40.8 electron volts. So we know the energy difference between these two states. So now let us write the equation as to the total energy evolved. If one atom, one ion would have reduced from E3 to E1, the energy evolved would have been this, but we have 0.5 moles of ions coming down from 3 to 1, therefore this becomes 0.5 into Na into 48.36 plus 0.25 into Na into 40.8 electron volts. On solving this, we get 24.18 plus 10.2 into Na electron volts. Now 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. On substituting the value of 1 electron volt over here and Na over here, we get the final answer to be equal to 3.31 into 10 raised to the power 6 joules. So final answer for the total energy evolved when all ions return to the ground state comes out to be equal to 3.31 into 10 raised to the power 6 joules. So the important thing which you should have learned from this question is how to draw the energy level diagrams, and you should remember the energies of at least the first 2-3 energy states. So final answer comes out to be equal to 3.31 into 10 raised to the power 6 joules.